Lesson 6-3, the nth roots and rational exponents. Finding the square root of a number and squaring a number are inverse operations, so they undo each other. To find the square roots of a, you must find a number with a square of a. The inverse of raising a number to the nth power is finding the nth root of a number. So the symbol, the nth root, indicates the nth root. So this radical symbol raised with the index of n, this means the nth root. For any real number a and b, and any positive integer n, if a raised to the nth power equals b, then ba is the nth root of b. For example, -2 to the 6th power is 64. -2 is the 6th root of 64, and 2 is the principal root. So remember, when you find the square root of a number, you can have two roots, a positive and a negative. The principal root is always referred to the positive root. An example of the nth root is the nth root of 36, which is read as the nth root of 36. Is this, in this example, n is the index and 36 is the radical, or the expression under the radical symbol. So again, you would have two roots when you find that, depending on which you're trying to find. For some numbers have more than one real nth root. For example, 16 has two square roots of 4 and a -4. When there is more than one real root and n is even, the non-negative root is the principal root. Suppose n is an integer greater than 1, a is a real number, and a is an nth root of b. When a is an even number greater than 0, one unique positive and one unique negative real root. You can always show that with a positive and negative sign. If a is less than 0, you have 0 real roots. You're going to have imaginary roots, but you're not going to have any real roots. And if a is equal to 0, you're going to have one real root. Just means it just crosses the x-axis at one point. A radical expression is simplified when the radical contains no fractions and no radicals appear in the denominator. So let's simplify a couple of these roots. So we need to find the positive and negative square root of 25x to the 4th. So I got to think, what do I multiply to get to 25, which is a positive and negative 5. And then the square root of x to the 4th would be x squared. So I know x squared times x squared is x to the 4th. So I would have an answer of positive and negative 5x squared. Letter B, it says the negative square root of y squared z to the 12th inside there. So to solve this one, if I'm trying to find, let me just rewrite inside here. I would have the negative and then y to the squared raised to the 12th power. I have to raise everything. When I raise a power to a power, you're going to multiply the exponents. So this is really y to the 24th, z to the 12th. And then when I solve this one, I'm now going to have a negative on the outside. And then I have half of the square root of y to the 24th is y to the 12th. Square root of z to the 12th is z to the 6th. So when it's an even exponent, you're just taking half of that to find the root. Letter C, you're trying to find the cube root. So to find the cube root of this one, you need to find out what do I multiply by itself 3 times to get 343. That would be 7. This one's only a positive because I have a positive number in here. If it was a negative, then that would give us a negative 343. So this would be 7. A to the 18th power. Now here I can just take the index and divide that by the exponent inside. So that would give us a to the 6th, b to the 2nd. Because if I do a to the 6th times a to the 6th times a to the 6th, 6 plus 6 plus 6 gives me 18. Same thing with b squared times b squared times b squared. That gives you b to the sixth. And letter D, find the square root of this. Square root of a negative number. Since I'm finding the square root of a negative number, I'm going to have a negative, or I'm going to have an imaginary root here. So that means I'm going to have a I involved. So let me just put this down. So this is a negative square root of negative 1 times the square root of 289. Square root of negative 1 is I, and square root of 289 is 17. And then half of 8 is 4, half of 4 is 2. So our answer would be 17I c to the fourth b squared. Moving on to a couple other examples. A here, we have a positive and negative. Square root of 36 is 6, x to the fourth. Cubed root of 64 is 4. Then a 24 divided by 3 is 8. And then b cubed, the cubed root of b cubed would be b. And the last one here, we have the square root of negative 441. So we have an imaginary number, so there's an I. Square root of 441 is 21. And then we would have c to the 6th, and then d to the 4th, or d to the 8th. And that would be our solution. More from example 1, write the simplified form of these. Square root of 196, square root of 196 would be 14. So we have a positive and negative 14x squared. This one would give us a negative 14x squared. And this one would give us 14i x squared. Now in this one, if you notice where the negatives are located, that dictates what our answer is going to be. Example 2 is simplified using absolute value. So the rule is when you find an even root of an even power and the result is an odd power, you must use the absolute value of the result to ensure that your answer is going to be a positive. So right now, I'm finding an even root and I have an even power inside here. Now we need to see if the result is an odd power when we simplify. So the fourth root, which means what do I multiply by itself 4 times to get 81? That will give me 3. And then x to the fourth raised, find the fourth root of that, that would be x. Now because I have an even index or an even root with an even power, and my result is an odd power, I have an odd power of 1, I would have to use the absolute value on that one. So that would be 3 times the absolute value of x. You could also put the 3 inside there if you want to, that's up to you. But for sure, the x should be put in the absolute value. Next one, the 8th root of 256. So one way to do it on your calculator is if you did 256, raise that to the 1/8 power. And that will give you 2. So here we have 2. And then I take the 8th root of y to the 24th. 24 divided by 8 is 3, so this would be y cubed. Since I have an even root and an even power, and I get an odd exponent in my answer, I would now have to have that part in absolute value, so it will remain as a positive answer. So I would have 2 times the absolute value of y cubed. Next, simplify these. So here, the square root, so this is even. So square root of 121 is 11. Square root of x squared is x. This is odd, so I have to have an absolute value. Next, fourth root of 1,296, so 1296 raised to the 1/4 power gives us 6. So we would have 6, and then 24 divided by 4 is 6. So now I have even, even, even. So my answer would just stay 6y to the 6th power. Would I have to put that as absolute value? You could still put that as an absolute value here. It's up to you if you want to. You don't need to do that based on the rule, because it still would remain, everything would still remain as positive. So either way would work. Next, rational exponents. You can use the properties of exponents to translate expressions from exponential form to radical form, or from radical form to exponential form. The expression is in exponential form if it's in the form of x to the nth power, where n is a exponent, and an expression in radical form is if it contains a radical symbol. So we're going to go from one form to the other. And when you have the expression b to the 1/nth power, that has a rational exponent, which just means your exponent is a fraction. And the rules for exponents also apply to these types of exponents as well. So when we're going to work on converting them. So if you look at this example very quickly, this is exponential form. Put that in radical form. This index, the denominator of the exponent goes as our index. The base goes as our radicand. Then you can simplify it to equal 5. So additional properties for any non-zero number b and any integer x and y with y greater than 1. B to the x to the divide by y is the same as saying the y root of b to the x power. Okay, so the numerator is the exponent of the base. The denominator is the index. Okay, so let's go through these rules that you need to pay close attention to when you're doing the addition property. An expression with the rational exponent is in simplest form when all the following conditions are met. It has no negative exponents, so make sure all your exponents are positive. It has exponents that are only positive integers in the denominator. It is not a complex fraction, so you can only have one fraction overall. And the index of any remaining radical is the least number possible. So you're going to only have one. You shouldn't have shouldn't have a whole lot of exponents inside the radical when you're solving these. So an example, write x to the 4/3 in radical form. So my basis for my radical is x. My numerator is the exponent, and my index is my denominator. So this would be the cube root of x to the 4th. That would be in radical form. Now, if I were to write the 5th root of x squared in exponential form, I would start with my base. This is my denominator. This is my numerator. So I'd have x to the 2/5. Next, simplify this one in radical form. So I have a radical. The index is the denominator, so I put that index there, and then I have x cubed. In exponential form, start with the base, and then this be x to the 4/9. Example 4, word problem. The expression c times 1 plus r per t can be used to estimate the future cost of an item due to inflation, where c represents the current cost of the item, r represents the annual rate of inflation, and t represents the time in years. Write the expression in radical form for the future cost of an item 3 months from now if the annual rate of inflation is 4.7. So we're going to start off with c times 1 plus r to the t power. Our t is the years, so they're giving us 3 months. 3 months is 1/4 a year. So I'm going to put 1/4 for my t. The r is the interest rate, but a rate as a decimal. So 4.7% is 0.047. So now I have c times 1 plus 0.047. If I simplify that, that's c times 1.047 raised to the 1/4 power. I need to write this in radical form. So this would equal c, and then I would have the 4th root because the denominator of my exponent is 4. And inside I would have 1.047. I don't need to put the 1 down there. So this would be in radical form. Next, ultraviolet light emitted from stars creates vivid colors of nebulae that you often see in photographs. The light the stars emit causes hydrogen to become ionized. The equation R equals 0.3 times square root of L divided by the cube root of N squared represents the radius of nebula, where L is the luminosity of the star and N is the density of the hydrogen gas. Write the equation in exponential form. So here I would have 0.3 times, this would be L to the 1/2 power because of square roots. Then we're going to divide this by N. The exponent is the numerator, index is the denominator. I could write that here, but I still have a variable in the denominator, so I don't want that to be that way. So then I would, to bring it to the top, this would be L to the 1/2 and then N. When I bring this to the top, that makes it a negative exponent, so negative 2/3. So this would be our equation in exponential form. Next, evaluate these. So 32 to the negative 2/5 power. So this is saying I need to do the reciprocal of 32, which would be 1 over 32 to the 2/5 power. The 5 tells us the 5th root of 32. The 5th root of 32 is 2, and then I have to square that, which will give us 1 over 4. Now you could also put this on your calculator. So if I did 32 raised to the negative 2/5 power, you get 0.25, which as a fraction is 1/4. Next, 125 to the negative 125 to the negative 4/3 power. Do the reciprocal, which is 125 to the 4/3. Cube root of 125 is 5. Raise that to the 4th power. 5 to the 4th power gives us 625. So our answer would be 1 over 625. Next, when we multiply like bases, we add the exponents. So 2/3 plus 1/6. So this would be 4/6 plus 1/6 gives us an answer of x to the 5/6 power. And then y to the negative 2/3. Again, we cannot have negative exponents in here. So if I write this, this would be 1 over y to the 2/3. We can't have fractions as exponents in our denominator. So to get rid of this, I multiply this by 1/3, because remember when I multiply like bases, I add the exponents. This is going to give us now y to the 3/3 or y. But whatever I do in the denominator, I must do in the numerator. So this will give us y to the 1/3 on top. Our answer is y to the 1/3 divided by y. And the last couple problems. I multiply like bases, I add the exponents. So this would be negative 4/12 plus 9/12. This will give us z to the 5/12. So I just got common denominators when I'm adding fractions. The last one here, this would be x to the common denominator of 8 and 6 would give us 24. So this would be a negative 3/24 plus 20/24 gives us x to the 17/24. So that's our lesson on nth roots and rational exponents.